Welcome to the 2021 SAS Global Forum. My name's Joe Perez. I'm Senior Systems Analyst at the North Carolina Department of Health and Human Services and Chief Technology Officer at Solentech Corporation. I'm happy to present my session, The Beauty and Brains of Actionable Data. On May 25, 1961, President John F. Kennedy, in an address to the U.S. Congress, issued a challenge to the entire country when he said, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth." This July will mark the 52nd anniversary of the day America met that challenge, just 8 years after the president threw down the gauntlet. But this monumental feat could not have been accomplished without using data that was made actionable. There were innumerable logistical issues to tackle. Things like timing the launch when the relative positions of Earth and Moon were optimal, choosing a landing site that met all the right conditions, supplying the needs of the astronauts, calculating fuel consumption parameters, figuring out how to get them there, and more importantly, bring them home safely. The list just goes on and on and on. Remember, the microprocessor would not even be invented until 1971. So the technology needed to conquer all these insurmountable obstacles simply did not exist. I mean, it's not like they could Google anything because the internet hadn't been invented yet either. They just had to make it up as they went. All of this that you see on your screen exponentially increased the value of having actionable data during the Apollo program to give NASA the insight needed to answer the incessant questions, make those tough decisions, and ultimately meet JFK's challenge. Well, actually, they exceeded it. Techopedia defines actionable insight as information that can be acted upon or information that gives enough insight into the future that the actions that should be taken become clear for decision makers. In other words, meaningful data that's useful for making a decision, answering a question, or solving a problem. But in data storytelling, with every data visualization, you have to start somewhere. You have a concept or an idea. You have as your end goal a completed visualization containing one or more graphs. Now, how do you get from concept to reality? I'd like to think of this data storytelling journey as a spectrum, along which I suggest 5 stages for best practices in getting from the idea on the left to the completed visualization on the right, while blending beauty and brains. Those 5 stages are conception, inception, perception, inspection, and direction. Now, the way I've listed these stages from left to right across the screen here, you might assume that I intend for them to occur one after the other. Maybe so, but they can also be concurrent and sometimes overlapping. In any case, we need to look at them in the light of a strategy that's comprehensive and with a positive mindset. You see, this is supposed to be an enjoyable thing to do, not a drudgery. And don't forget, before your concept becomes reality, it needs to be visualized and it must stand up to scrutiny. I'll give you more detail on that in just a few moments. Let's jump right in. First stage is conception. You have to start the race somewhere. How do you do that? I see the key word as articulate. As you articulate the need, it's important to understand your audience. Those are the people that'll be consuming the data. Visualization Senior Director Tricia Onderud has said, your audience determines the depth of your data communication and the presentation method. You've got to know your audience. I mean, that makes perfect sense to me. Speak to people at their own level using terms that they can understand. You must also know your data. That's a given because you need to articulate what you're going to do with the data, and doing so is where your concept or idea is conceived. Now, the most important thing to be articulated is the purpose for your data. That is, what are you trying to show? Are you showing comparison, distribution, composition, or relationship? Well, the answer to that determines the type of visualization that'll be the most appropriate for the story you're telling with your data. And that leads to even more questions that guide you to refine your approach along the way. Think of it as a hierarchy. Dr. Andrew Abella, chairman of the Department of Business and Economics at the Catholic University of America in Washington, D.C., has come up with an amazing graphics tool that I believe masterfully articulates the need and sets the pace with these four categories that he's identified for data storytelling. Here's a look at Abella's chart chooser cheat sheet. Let's take composition as an example. You start asking questions. Does it change over time, or is it static over time? And if it changes over time, are there many time periods or few time periods? If there are many, well, are the differences relative or are they relative and absolute? So you see how certain questions lead to other questions as you proceed along the decision tree, and that helps you to refine your approach and come up with the right graph, at least the ones that are considered to be the best practice. That's the stage of conception. Second stage, inception. Once the race has been started, here's where we need to make the case. Keyword advocate. Make the case for expressing the concept visually. Folks, this is very powerful for a couple of reasons, according to Mike Parkinson, founder of Billion Dollar Graphics. He says we're affected by graphics in two ways, cognitively and emotionally. First of all, cognitively. Graphics speed up the way we communicate and help us better understand and more clearly remember what we've learned. They're like visual clues we can use to unlock a deeper meaning and focus our attention so it's more likely we'll remember what we've seen. Secondly, we're affected emotionally. Graphics also improve our mindset and affect our feelings. They connect with our creativity by stimulating different parts of the brain, leading us to more fully understand what's being presented. Do you realize what Parkinson is saying here? We're affected both cognitively and emotionally. In other words, graphics get a hold of both our brains and our hearts. Hey, what better marriage could you possibly want? Anytime that you're able to touch both the brain and the heart, man, oh man, you've got something good going. See, that's both beauty and brains at work. British data journalist David McCandless said in a 2010 TED Talk that sight by far has the highest bandwidth of any of the five senses. About 80% of the information we take in is by eye, he said. Additional research in the years since then shows that it's more like 90%. A couple of European research professors, Emery Sawyer and Robin Hogarth, teamed up on a study in which three groups of economists were asked the same question concerning a particular data set. And the results of their study seemed to support McCandless's TED Talk claim. Now, one group was given the data and a statistical analysis of the data. 72% of those economists couldn't answer the question correctly. Another group was given the data, the statistical analysis, and a graph. They did do better than the first group, but not by much. 61% of those economists missed the answer as well. A third group was given only the graph, all right? No data, no analysis, nothing, just the graph, and only 3% of them couldn't get it right. This certainly makes the case for visual representation of data, and it is certainly something that we can advocate. That's the stage of inception. Third stage, perception. Once you've started the race and you've made your case, it's time to motivate the base. Keyword, educate. Hey, we're not going to get very far in this data storytelling process if either the target audience or the stakeholders are not on board. So it's up to us to educate them, making them realize they've got some skin in this game. Look, they can't take ownership or provide the necessary backing financially or otherwise if they don't understand what you're trying to present, or if they can't see what's in it for them, or if the data visualization does not help them to make a decision, answer a question, or solve a problem. Now, how do I do this? By understanding some basic principles. And, that's foundational to any educational initiative, isn't it? For instance, you ever heard someone say, he's all talk and no action? Or she's all beauty and no brains? Or this project is just form without function? So it begs the question, does form follow function? Well, I'd have to say yes. It's the age-old argument. Is it pretty or is it right? Does it look good or does it work? Now, this leads to yet another question. What do we mean by form and function? Okay, function is what you do with the data. That's the brains. Whereas form is expressing functional outcomes in the best possible way. That's beauty. Here's some best practices or cardinal rules that we need to keep in mind to ensure function gets the right priority over form. Let me show you some examples of what not to do and how to deal with it. First of all, pie charts. It's important to understand that pie charts are supposed to show the parts of a whole. You'd think people would get that, but not everybody does. I'll show you what I mean. Take a look at the pie chart shown in this fuzzy screenshot from a TV newscast. I see a couple of problems with this chart right off the bat. First of all, look at the numbers. They add up to 193. How can you have 193% of a single pie? That's almost 2 pies, isn't it? Secondly, check out the sizes of each slice. 70's bigger than 60, isn't it? But yet, how come that 60 slice looks bigger than the 70 slice? In reality, the survey questions used in putting this news report together allowed for multiple choices. That is, respondents were able to indicate support for more than one candidate. Aha! Now you see why the numbers add up to greater than 100. Okay, that in and of itself isn't necessarily a problem. The problem here is that is not the way you show things in a pie chart. We can therefore conclude that this pie chart is misleading. And in this particular case, a bar graph would have reflected the data much more accurately. Maybe something like this. Same data, but presented in a way that is not misleading. What about line graphs and bar charts? Well, another best practice is that the y-axis should have a consistent scale. Look at the sample line chart showing how the compound annual growth rate by year for a set of fictitious provincial retail sectors has changed over time. Upon first glance, you would assume that there was a huge spike between 2013 and 2014. You see that? But look more closely at the odd way in which the vertical axis is scaled. From 28 to 33%, thus making the change between those 2 years appear to be fairly drastic. I'd call this chart a little bit misleading. By contrast, look at the chart on the right. Same data, but with the y-axis scaled to start from 0. You can see maybe a more realistic depiction of the CAGR percent trend over that same 5-year period of time. I'd say that second chart is not misleading. What's the point? When blending brains and beauty, be consistent and avoid making changes over time appear to be more drastic than they really are. Here's some other best practices that influence perception. If you're plotting something chronologically, it should go from left to right, that is the past to the future, along the x-axis. If you're measuring quantity, plot it along the y-axis with the smaller numbers at the bottom and the bigger numbers at the top. And then be consistent when you're using colors, remembering that there are some universal constraints like red means stop, danger, decline, whereas green means go, safety, growth. And finally, keep your shaped graphical elements proportional to each other. Master statistician and Yale professor Edward Tufte advocates not exceeding what he calls the lie factor. Essentially, it says that the representation of numbers as physically measures across the surface of the graphic itself should be directly proportional to the quantities they represent. Now, as a mathematical equation is often expressed like this: the size of the effect shown in the graphic divided by the size of the effect shown in the data should never be greater than 1. Let me illustrate. In one of their iterative product releases for a new iPad model several years ago, Apple touted its greater battery capacity over its predecessor. Rightfully so. I mean, a 17% increase is pretty significant. But look at this graph, though. The battery icon on the right, representing the capacity of the new iPad, looks like it's maybe 3 or 4 times bigger than the one on the left, representing the predecessor. That is certainly way more than 17%. And as much as I like my iPad, that, my friend, is a misleading graph. So you started the race, you made your case, you motivated the base. Now, give it some space. The fourth stage of the spectrum by asking the question, does it stand up to scrutiny? This is inspection, with the key word being investigate. Hey, being totally transparent helps you to avoid the pitfalls of bias and unethical use of your data upon inspection. And when you've done your due diligence, you won't cringe when you get these questions. You know the ones I'm talking about, your favorite ones. Did you ensure data quality? Where did you get your data? How do you know it's right? Right? You won't be bothered by them. They won't intimidate you. Now, here's a trend that sounds a little counterintuitive. The more complex your data model is, the less likely your people will be to embrace it. To that point, suppose you wanted to buy a blender for your grandmother, and the only 2 choices you had are the ones on this slide. Now, which one do you think will be the better choice, huh? Enough said. As you let the data behind your visualization project stand up to inspection, it's important to be aware of the difference between impact and influence and how that plays into making data actionable. Now, for the sake of time at this point, I'll just show you the next couple of slides very quickly and tell you that an expanded version will be made available. After having started the race, making the case, motivating the base, and giving it some space, we now come to the 5th and final stage of the spectrum, direction. It's time to put it into place. Keyword here, effectuate. I see this implementation cycle as a 4-fold iterative process. You start off by deploying your solution using whatever organizational protocols and methodologies you have in place. As your stakeholders start using the solution, they'll discover issues. You then analyze those issues and discern the right course of action to address them. And finally, you start developing the remediation for those issues. And guess what? The cycle starts all over again. Deploy, discover, discern, and develop. And hopefully, you'll improve upon your solution with each iterative cycle. That is an effective direction because it leads to progress. So in conclusion, you ask, can I truly turn my ideas into reality? You bet your boots you can. While developing your solution and moving it along these stages of the spectrum, try to ensure best practices are followed. Graphs and data visualizations are only as good as the data they portray. They should be no more complex than the data they portray, and they should never paint a distorted picture of the values they portray. Don't forget Tufte's Lie Factor, and never let the size of the effect shown in the graphic be greater than the size of the effect shown in the data. All right, one last review and summary. Here are the 5 stages of the spectrum. For the sake of time, I'll just show them to you on the screen. I'm convinced that if you articulate, advocate, educate, and investigate your data, you should be able to effectuate a solution. Enterprise account executive and expert data storyteller Spencer Sobczak once said, data storytelling is both an art and a science. Our data visualizations are the most powerful when they find this balance. Hey, you now have the tools. So let's balance art and science. Let's combine form and function. Let's blend both beauty and brains. Ladies and gentlemen, with actionable data, NASA exceeded President Kennedy's monumental challenge more than 50 years ago and not only sent astronauts to the moon successfully, but they also returned them to Earth safely. They definitely knew how to balance art and science, beauty and brains. Remember, data is actionable only when it helps you to make a decision, answer a question, or solve a problem. Now, what can you do with actionable data? You may not be putting them out on the moon, but the information technology space, you can certainly put the heat on your competition. By using these tools and best practices that I've shared with you today, I leave you with this challenge. Turn your ideas into reality by making data actionable. Thanks so much for watching.